of today's FTP. Now I call upon Harni to introduce our chief guest.
It's my immense pleasure to introduce today's chief guest, Dr. Tushar Kanti Bera. Dr. Tushar Kanti Bera completed his BE degree in Electrical Engineering from University of North Bengal, M.Tech in Electrical Engineering from University of Calcutta, and his PhD from Indian Institute of Science, IISc. He had worked as a postdoctoral researcher in Onsei University, South Korea from 2012 to 2014, and worked as a postdoctoral fellow in King Abdullah University of Science and Technology, KUST. Saudi Arabia from 2015 to 2017. At present, he is working as a postdoctoral researcher Associate University of Arizona, USA since 2017. He has more than 12 years of research experience and more than 3 years of teaching experience in different institutes and universities in India and abroad. His major teaching and research interest involves biomedical engineering and technologies, including biomedical instrumentation, medical and biomedical imaging, and other electronic instrumentation technologies for biomedical, medical, and clinical applications. In his career, he received more than 20 awards like DST Fast Track Scientist Fast Project Award, Best Paper Award, Best Oral Presentation Award, and etc. from various organizations. He is a life member of ISOI, ISTE, and AMPI, and student member of IEEE and IEEE Communication Society, ISEBI, and SPIE. He is a receiver for various international journals and social media editor for Journal of Electrical Bioimpedance. He had published more than 15 international journals and more than 30 international conferences. On behalf of our EEE department, I request our chief guest, Dr. Tushar Gandhi Bera, to take over the session.
Hello. Yeah, thank you very much for the introduction. Little bit just correction that I'm working as an assistant professor in the Department of Electrical Engineering at the NIT Durgapur presently. So I was working as a postdoctoral researcher in the University of Arizona. So after that, I have come back to India and I have joined NIT Durgapur since December 2018. So it's my pleasure to be a part of this FDP. And I'm very much pleased for getting an opportunity to contribute to this faculty development program on electric vehicle design and development. So though I have worked for a long time in the field of biomedical application, biomedical engineering applications, but my major field is electrical engineering, and I have contributed majorly in the field of the electrical and electronic instrumentation and measurement. And presently I'm working in the field of electric vehicles, and for that I would like to share my knowledge and experience in this field. So I have given the title of the talk as electric vehicles and plug-in hybrid electric vehicle, that is PHEV, and a smart charging. So need, applications, and the research opportunities. Why the smart charging is required? So we will discuss about the electric vehicle technology, electric vehicle in the hybrid form, plug-in hybrid electric vehicle. And after that, we will go to the charging part and we will discuss about the smart charging. So just I need 1 minute for sharing the screen, and then we will start in detail about the talk. So I request you to just give me 1 minute. My screen is visible now?
Yes, sir. Visible, sir.
Yes,
Okay.
sir.
Sir.
Hello. Yes. So very good afternoon all. So we will discuss about the electric vehicles and plug-in hybrid electric vehicles and the smart charging. So the electric vehicle is a vehicle which runs with electricity. So it has two words, that is electric and vehicle. We know vehicle, the means of conveyance, means if we want to transport either the people or from goods, we need to have some vehicle. It may be in form of a cart or it may be automatic. So in modern era, we have automatic vehicles which are known as also automobile say systems. But the term electrical, it came from the electrical power system or electrical power. For moving something, even it is an object, our reason should be power, means power should be applied, power or energy should be applied, and that power will be utilized to convert into the mechanical motion. And as it is named as electric vehicle, so it will be definitely the power applied will be the main source of power will be electrical power. So electrical power is generated in the particular place, and that place is known as the electrical power plant. After that, the power is transferred from one part to the other part, means the region where the power will be utilized through the system which contains transmission system for long distance transfer, and the distribution system where the power is distributed in part, and the end users where the appliances are connected. It may be lights, it may be fans, or it may be any other motors running in industry. So domestic or commercial utilization of electrical power, entirely it will be termed as utilization. And electricity will be in two types, direct current, because in case of the direct current, the electrons or the charge carrying particles, whatever it will be considered as electron flow or the flow of holes, that will be continued in a particular direction. And that's why the polarity of the DC source will be fixed. And if we plot the voltage or current along the time axis, we will find somewhat like this. So it will be constant over time. So amplitude will be fixed. If it's a ideal source or a battery output. So during the running condition, we will find a constant voltage or current, and there will be also no polarity change. So always it will be either positive or negative depending on the property of the source. But in case of alternating current, we see that electron flow or the flow of charged particle will be continuously changing, and the rate of changing will be fixed by the frequency of the power generation, in which speed the generator is running and how many poles are there. So depending on that, the frequency will be decided, and the change in polarity will be there, as well as if you see the time varying nature of any alternating quantity, say voltage or current, we will see that the amplitude is also varying. It is starting from 0, it is going to its maximum value, and again it is going to 0, and that is called, say, 1/2 cycle. After that, the entire polarity will be changed. It will be going to the negative direction. So it is crossing the time axis, and it is also giving some negative quantity. And also in the negative quantity also it is going to the minimum value, because minus of maximum value means it will be minimum value, and then it will be again going to the 0. So as per the property of the generator, the rotating machine, what is responsible for generation of electrical power, that is generating the alternating voltage or current which is following the sinusoidal curve. So this is the sinusoidal wave which may be found as either as a voltage or current in our AC circuit. So this is the one kind of, say, conductor is rotating in a field, and we will be able to get some sinusoidal wave. So AC generation means there will be the alternating power generation, and if there will be some carbon brush, it will be converted to the DC generation, but in alternator or generator, power will be generated in AC form, and if we need a DC power, we can convert it to the DC using the commutator and brass segment. So in case of three-phase generation, because if we generate the electrical power in three-phase, then we will get three separate sinusoidal waves, generally represented by red, yellow, and blue colors. So there is no other significance in the electricity. There will be identical sinusoidal wave will be generated. There will be no color in the practical case, but for denoting or separating them from each other, and by convention, we generally put this type of three colors for representing the sinusoidal waves which are generated 180 degree apart from each other. And a single magnet with two poles or multiple poles can be rotating in a magnetic field in the stator winding, which are fixed, and the electricity will be generated as a three-phase power as shown by this picture. So as we have already discussed, that if we want the DC power generation, we have to do the similar work. We have to perform the similar work, but there will be another component, generally two components, as commutator and the brass. And the direction of the EMF generation will be obtained by the rule of Fleming's right-hand rule, and it is called also dynamo rule or DC generator rule, or direction of the EMF. In case of motor, the opposite thing is done. In the case of generator, we generally apply some mechanical power to the shaft of the generator, and shaft starts rotating in a magnetic field, and we get some electricity in the stator winding. So we are applying mechanical power and we are generating electrical power. But in case of motor, the reverse is done. So we give some electricity to the winding, and the rotor will start rotating. So that type of machine, rotating electrical machine, is called electrical motor. It may be DC or AC. So in case of DC motor, construction wise, it will be almost similar to the DC generator. So there will be commutator segment and the brass, and there will be one magnetic field. So whenever the magnetic field will be there, and if we give some electric power to this conductor, the conductor will start rotating, because the conductor will carrying some current, because we are supplying some DC power to this, and automatically there will be current, and that current will create some magnetic field, and that magnetic field also will interact with the stator magnetic field, and that interaction will make this rotor rotating. So this is the basic principle of DC motor, and that type of machines are very, very important for electric vehicle, because electric vehicle, we need to move the car, and for moving the car, definitely we need to have some rotational motion in the wheel. So there will be wheels. Generally we will be discussing in this discussion for four-wheeler, and though the electric vehicle is also possible for developing some larger vehicle having six-wheelers like bus, truck and all, and even for the more number of wheels. So if the four-wheeler is concerned, then we will see that the car or the automobile will have four wheels, and the wheels will be rotating, but all the wheels will not get power in most of the cases, though in some cases all wheels are provided with power. So whenever the mechanical power is to be transmitted or is to be applied to the wheels, there should be some other mechanical device or electromechanical device which will give that mechanical power or generate that mechanical power. So in case of IC engine based automobiles, which are very widely used even till today, so that type of automobiles or the vehicles will have one petrol engine or diesel engine, that is called gasoline engine, or more technically it is known as internal combustion engine. So why it is called internal combustion engine? Because there will be some combustion phenomena will be happening inside that machine, and that is nothing but the burning of some liquid fuel which is filled in the tank of the vehicle, say petrol or diesel, and then the combustion will be made inside the machine. So internal combustion engine will create some mechanical motion in a piston, and that piston motion is converted to a rotational motion. So there will be a shaft, and that shaft will rotate, and that shaft rotation will be the source of mechanical power, and that mechanical power will be transferred to the wheels of any vehicle. So motor is replacing that internal combustion engine. So, and we are getting the vehicle as electric vehicle. So most of the other things will be almost similar, say other frame, the transmission unit, gear system and all. They are maybe similar, a little bit different from the conventional vehicle. But in case of any electric vehicle, major difference is that the internal combustion engine will be replaced by electric motor. So the direction of the electric motor shaft rotation, or the force created, that can be found by the help of Fleming's left hand rule, what we studied in our basic electrical engineering. So now electricity is well understood. With a brief introduction, I explained this because there may be some other participants which may not be from the electrical background. So just for giving one very basic idea about electricity and how the electric vehicle is called and why the electric vehicle is called electric vehicle. So that's I have given one brief introduction. And now I will come to that other word that is there in electric vehicle, that is called vehicle. So what is a vehicle? As I already mentioned, a conveyance system used for transporting people or goods, especially on land, such as a car, bus, lorry, train, ship, or cart, etc. Many things. And what is EV? A vehicle driven by electricity, as simple as it is. So by this definition, our vehicles which are called train or moving in a track or rail, so railway system, those vehicles which are taking electrical power from the overhead lines, those are also electric vehicle. But as per the time constraint, so we will not be considering those things as electric vehicle in our discussion. So we will be discussing about the electric vehicles who are moving on the road. So road transport vehicles driven by electricity will be our target point or target topic. So vehicle may be several types, as it is shown by this picture. And when the concept of the vehicle came, so when we were there in the jungle, or we are not very much civilized, so we felt the need of wheel, because we had to bring some material, or we need to go from one place to other place, and we need to transport some goods also from one place to other place. So whenever we are feeling tired for doing that, we found the animals are suitable for sharing our work. But as those animals are also living objects, so they have their own capability and they are also feeling tired. And sometimes for heavy vehicles, it's not at all possible. So we started thinking about some easier means, and we started with the sledge, where the vehicle was just like a less frictional material, or it was very say shiny bottom, so that it can be dragged very easily, and some person can sit on that, and it can be also dragged by either few other persons, whatever is only by this picture, or it may be dragged by any animal. And also it has some limitation, and a lot of energy was lost in the friction. And so we started out thinking what will be the next step. So people realized, because human being has brain and that has the thinking power, so we started thinking what may be the solution. So we realized that something can be very easily dragged if there are some number of logs, and that logs will be rotating, and the heavy material will be dragged very easily with less force. But that was limited, because how many logs can be put in a particular direction, and also logs may be misplaced, it may be displaced, so there may be several problems. And then the people understood that if the logs are replaced by some circular object, this kind of object, and having a particular hole that can be fixed very nicely with a cart, and we found our bull cart or some horse cart also. Even some cart are also dragged by human beings. So gradually we found, or we are moving towards the development of the conveyance, which are called say vehicles. So initially the material was dragged by log, then the sledge, and the combination of sledge and the logs, and then if we make some grooves in the logs, then it was found very good. But a lot of material was lost, and we found that if the materials are cut as a disc, and we can make a hole, and we can make the axle and the hole, so that we can fix it as a wheels, and that will be found as most easier and a very comfortable device for dragging something, and whenever we realize that balance is not there, so self balancing is required in the situations, and there we put some more wheels, either starting from 3. Even today also we found so many 3-wheelers like auto and totos, and now we found a lot of advanced wheels which are developed with tires and tubes, and nowadays the age of say tubeless tires with the help of some gels and all, where the damage of the tire and tubes will be sometimes somewhat say reduced. And we found that solid wheels were very heavy. After that we started using the spokes, so that heavy wheels will be strong enough but it will be lighter, so that the vehicle weight will be less and it can move for a comparatively less amount of energy. So like that we found the wheels, and then we can find the development of the car with the steam engine, starting from some say horse cart or any other steam engine vehicle. So there are the timelines by which we got the we can see the development of conveyance, and here are the development of say starting from walking to the car, and there are the development of ancient wheel to the modern wheels. And there are several model development, construction wise development. There may be sometimes 3-wheeler and 3 wheels, and there may be 4 wheels, and there may be some other facilities also. So it is giving one comparison that 1880 the vehicle was looking like this, and then 2019 or 2020 or 21 the vehicles are very much modern. So evolution of car. In this evolution, many people and many inventor or many companies, industries have given their own contribution. So among that we can remember Carl Benz, say founder of the Mercedes-Benz company, and gradually his company has developed several types of car and automobiles, and their contribution was remarkable. And nowadays we are at the era of green design, that is the electric vehicles. So in 20th century we found that, and we also find some type of very basic vehicle starting at the 1886 or similar time. Some internal combustion engine was coming, and due to that invention of internal combustion engine, the entire scenario of automobile was revolutionized. Earlier it was steam engine, and steam engine means it should be having some fuel and generation of steam. So the whatever is there inside a thermal power plant, the similar unit was there in a small place, and it was not very much comfortable, because that time the coal was used for making the heat, and that time it was not possible to have that compact IC engine. So vehicle was very big and also having several limitations. After that, when the internal combustion engine, that is IC engine, was invented, and after that we found the drastic change in the automobile technology. And after that we realized if we use the automobiles with the IC engine, so there will be always some pollution problem, because the IC engine takes the gasoline or any other fuel, liquid fuel or gaseous fuel, which is burnt, and carbon dioxide is produced. So few slides are also given here for giving the look of the development of the car, and some say major companies. There are several major companies, but I have put, as per the space of the slide, I have put few of them taken from the internet. So some websites are also mentioned somewhere from where we have taken the pictures, but I have taken all these pictures for so non-commercial purpose, just for education and academics. So it will be whenever I will be sharing all the slides. So my request is that to use only for the academic and educational purpose, as I have taken say from the internet. So these are the several development again, and whenever the IC engine was used for a particular vehicle, so carbon dioxide was generated, as I was discussing. So due to that pollution effect, the electric vehicle concept was thought. So if we replace the combustion of fuels, then with any means by which we can stop generation of carbon dioxide, then we can say that vehicle will be the green technology will be coming from the green technology or introduced with some green technology concept. So electric vehicles are cars driven by electricity, understood, well understood, and it is the future because our earth has limited amount of fossil fuels, and limited amount of fossil fuel means one day it may come when the fossil fuel will be finished if we don't take any step. So that's why the step, a major step, is to use the electric vehicles, and that's why that was main say aim or main goal for introducing the electric vehicles. And whenever we will have some new technology, it will have several problems, it will have several advantages, it will have several limitations. So, and as a researcher or scientist or the academician, our duty is to study those issues, important issues, and to improve the system or the technology by giving some solution to the practical problems or limitations. So here we are going to discuss about the charging of electrical vehicles, and due to the charging or the usage of electrical vehicle, what problems may be coming in our society or in our system, automobile system, which may raise some critical issues, and those issues, how those issues can be taken care. Otherwise, what type of problem may come. So all these things will be discussed, covered by this discussion. So as I told, that electricity will be taken or will be used in a car. Now in case of the train, that overhead lines are there, fine, and overhead lines will have a alternating source of energy, and that source of energy will be provided, or source of power will be given to the vehicles at a very high voltage. Say it will be supplied from the overhead line at around 25 kilovolt, and that 25 kilovolt will be taken to the vehicle engine, and it will be converted into say lower level AC voltage with the means of say transformers, and then it will be distributed to the motors connected in the wagons and the engine, and that motor will run, and automatically we will get some motion in the electric train. Those electric trains are also electric vehicles by definition, we have already told. So that type of AC vehicles are moving in a particular direction, in a particular, along a particular track, which is called rails, so railway. In case of our discussion, we will be concentrating on the four-wheelers which are taking the electricity and without any overhead lines, because in case of railway there must be one overhead line from where the electricity will be taken, and as the overhead line is to be installed, so automatic the direct alternating power can be also supplied, because from any other grid or any other power system part we can take that power and we can supply to the overhead line installed for the electric train system. But in case of four-wheeler driven by electricity, there will be no track, so it will be moving in a many direction in a say surface road and without any track. So there will be no overhead line, there will be no supply from the grid directly. So what may be the solution? Solution may be there may be some device which can store electricity, or there may be some device which can generate electricity from the sunlight. So many research units or research centers are working on some direct generation of electricity with the help of some solar cells, and it can be taken to it can be used for feeding the electric motor. But that type of system will have several limitations, especially the amount of the power required for moving a vehicle may not be sufficient always, because a lot of photovoltaic cells and photovoltaic panels should be installed to get a particular amount of electricity which will be suitable for dragging a car. And another thing will be that there will be also requirement of some battery, which will be, because depending on the solar light intensity, the amount of the power will be fluctuating, and it is better to feed a motor with constant voltage power and say constant amount of power. If it is required for less amount, that is okay, but it is better if we have a controlled source. So even in the photovoltaic cell also, photovoltaic system also, some batteries are connected generally to store the charge first, and then it will be stored in a battery, and if we need a DC supply, then we will take the power from directly from the battery, or if you need the AC supply, we will be having some other circuit called inverter, which will convert the DC supply to the AC one. Now, in most of the electric vehicles, that type of photovoltaic panels are not installed on the top, but other means storing devices called batteries. Those batteries will be utilized for storing the charge, and whenever it is required, that power will be taken from the battery. So this is the concept. So first of all, electric vehicles, two words, electric and vehicle, we have already understood. Electric vehicles means the vehicles runs with electricity, and what type of electricity may be, AC or DC, both. So in case of the overhead line fed electric trains, these are running with alternating supply. So it is the vehicle, electric vehicle, which are running on the over the AC supply. And in case of the DC, so definitely that power will be DC, and that will be stored in a particular storage device called battery, and that battery will be feeding the electrical motor. Now this DC will be storing inside the battery, and battery can be rechargeable in otherwise once the battery charge will be finished, so then battery should be discarded. So it is not the say common practice that for a vehicle, if the vehicle weight is say more, definitely the amount of power which is required for driving it for say 50 kilometer or 100 kilometer in standard distance, the battery size will be more, and that much big battery after one charge, if it is discarded, then there will be huge financial loss or economical thus will be dropped, economic will be dropped. So there will be, it will be less economic if we want to discard it after first use. Just what we do for our double size battery for less power electronic gadgets or devices, we use the batteries and we throw it, we discard it whenever it is found that it is not rechargeable. But in almost 100% electric vehicles, batteries are used for rechargeable batteries. So it is standard size electric vehicles will be having say rechargeable batteries, and that rechargeable batteries are required to be charged regularly and repetitively whenever the charge is discharged fully, or certain amount of charge will be kept sometimes. So whenever the need will come for charging, battery is required to be charged. But that DC charge may be fed to a DC motor to drive the vehicle, or the DC source or DC battery supply can be converted to AC one if there is one kind of motor called AC motor. So that type of AC motor will not be able to run with the DC. So definitely battery supply is DC, so which is not suitable to connect to the AC motor. So intermediate circuit or say called inverter is required for converting DC to AC. So that type of vehicle, battery charge is DC and that is converted to AC, and then the AC motor is run. So what will be the advantage and disadvantage for the electric vehicles? Car driven by electricity, definitely it will have initial cost, and that initial cost is for several reasons. First of all, a huge amount of money is to be spent for developing the battery pack, because for getting a standard mileage distance or standard distance which can be covered by a single charge or the battery power, whatever is there stored inside the battery. So for that, a huge amount of money is required to develop that battery pack system. Running cost will be an attractive point for the electric vehicles, because as we are not consuming the fossil fuel, so the fuel is only the electricity which is taken from the grid. Now don't be confused that electricity is taken from grid means it is not taken from grid and directly given to the motor. It is taken from the grid and it is given to the electric vehicle for charging purpose. So I will explain the procedure of the charging. What we are discussing about, say, the running cost. So whatever charge is there inside the battery, that will be utilized, and it is observed that it is much lesser than the running cost of one fossil fuel vehicle. Facilities will be definitely there, otherwise no technology can persist. So advantages will be there, and also every technology has its own problem and limitations. So problems also will be there, both will be discussed. So why electric cars? To save fossil fuel, to reduce pollution, to measure issues. So those issues actually driven our mind to develop electric cars. Extra benefits, reduce running cost. So running cost is reduced, and facilities, many other advantages and few disadvantages are also there. So just for comparison, the automobile driven by the IC engine, that is fossil fuel car, a modern car picture I have just given, and this is fuel car which will be utilizing the fossil fuel either from the petrol bunk or any supplies unit, and then electric vehicles which will be taking electric power as the fuel, and that will be taken as the electricity, and there will be some charging point, and that charging point may be connected directly to the battery or through any circuit. So why that type of difference is there? Because battery is a DC storage unit, and whenever we are connecting some load, battery is delivering DC power, and whenever the charge is finished, so battery is required to be charged again, or it is called recharging. So during the charging or recharging, the electric power is to be given to the battery. During that time, battery will be working as a load, and from where we are taking the power, that will be working as a source. And now if the source is giving the electricity in form of DC, that can be connected directly to the battery or even through any converter or any instruments. But whenever this power is AC, then the car should have some instrument which is converting the AC to DC, because battery charging needs DC, and for that this type of charger, if it is installed in the car, that is called onboard charger. But if the charging circuit is there outside the car, it may be inside any particular station called charging station, or any post which is called looking like a box, charging post or charging block or charging unit, then it is called off-board charging system. That means there may be several supply lines, alternating supply lines, whatever is in here or anywhere else it may be nearby, and from there it will take the AC power to this unit. That AC power will be converted by this converter. This is called the rectifier and regulator. All circuit units will be there as a standard procedure of the say rectification from AC to DC, and that DC power will be given to this unit, and this is called off-board charging unit because it is not on the inside the vehicle. So onboard charging system means there will be charging circuit inside the car, and AC power can come directly, and this AC power will be converted to DC inside this car by this charging circuit, and then it will be fed to the battery. For off-board charging system, AC power will come to the charging unit outside the car, and that will be converted to DC, and then DC will come directly to the car. So the components of a car, it may be say automobile driven by the IC engine or electric motor. If we see a car, we will find first of all the body of the car. There may be wheels, there may be some spare wheel also, lights and several doors, mirrors, glass, all these things will be there, which are very well known to all of us. So there will be the outsides, but those are not the entire thing. So this is only few things, very simpler things which are easy to understand what those things are there. But the technology, whatever is there inside the car, which is almost amazing and very complex compared to the outer view. So those are the system what we generally don't know. So many of us are not aware about those unit. We know the names, but how they are working may not be very much clear, or may be clear which are working or which are expert in this field. Definitely they will be having better knowledge about that, and depth knowledge will be there. So I'm just discussing for the entire audience that in case of any automobile running through IC engine, we'll have say one IC engine, definitely as it is suggested by its name, IC engine car, and that is an engine, that is a mechanical device which is converting the chemical energy stored inside the fuel. So fuel is taken from the pump. This is the fuel inlet. So fuel, this is the exhaust maybe, or it is the fuel tank. It is the fuel inlet. Here cap is the fuel. So this fuel input will take fuel from the fuel pump, and it will be stored inside this tank, and then fuel will be pumped by a fuel pump, and fuel pipeline will be there from the place of the fuel tank to the IC engine. Fuel tank may be kept in many sides, but it is generally kept at the back side or rear side of the car. And then the IC engine, which is located here near the front wheels or the front part of the car, it will burn that fuel and it will generate mechanical power, mechanical unit, and the shaft will be rotating, and that mechanical power will be transferred to the wheels. To which wheels? It may be front wheels, it may be the rear wheels, but where that power will be transferred and will be given to a particular set of wheel, those wheels will be called as drive wheel. So the wheels where the mechanical power is coming from the IC engine to those wheels are called the drive wheel. So there will be two major parts. One is mechanical and electrical. Why the electrical part will be there in case of automobile driven by IC engine also? Yes, definitely, because we have some lights. Car will have some lights, indicators. There will be another component which is called the spark plug. So why the spark plug is required? Spark plug may be hard by several people, and the thing is that whenever we are lightening our say gas in a cooking place in kitchen, we need to use some gas lighter, and if we press the button of the gas lighter, we see that tiny spark is coming out, and which is given to the gas oven where the gas outlet is there, and whenever the gas is mixed with that or come in contact with that tiny spark, the fire is set. So for lightening any candle also, we need a matchbox, because we need to create the fire first, and then we need to give that fire in contact with the candle, and then it will be lighten up. Now in a similar case, if we have a fuel, inflammable fuel inside an engine called IC engine, then the setting of fire, there should be a device which will set the fire. So that device is nothing but spark plug, and spark plug will create some spark. That's why it is called spark plug, and that spark will be caught by the fuel and it will start burning. So the engine will start. So that type of spark plug will generate electricity with the help of some battery. So don't be confused about this battery, which is always there in any kind of vehicle, either in electric vehicle or automobile vehicle. That vehicle battery is called auxiliary battery, and that battery doesn't have any relation to the driving force generation, what is done in case of electric vehicle. So that battery is always found in case of gas, say IC engine vehicle and electric vehicle also. So this circuit is different. It is for lights, it is for actuating some device. If the doors are automatic, if the doors are motor driven, there should be some motors, small motors for glass and all. So if there is a open door in the top, there will be also motor driven doors. So those type of things will be done by the source of this battery or anything else. But the other battery pack which will be there in electric vehicle, that battery pack is called traction battery pack or traction battery source. That will be giving the majorly the power to the motor, and motor will give some mechanical force in the wheel. So electric components, I told that lights, spark plug, the main battery means auxiliary battery, and this battery will be giving the power to the lights and all, and other sensors, actuators and all. And whenever the vehicle will come for the electric vehicles, that type of battery also will be there, and other battery will be there. And the classifications, so as per the discussion, as a summary, we can classify the vehicles, say fuel vehicles and electric vehicles. And fuel vehicles, there will be petrol or diesel will be the main say energy generation components or the fuels, and there will be also sometimes fuel cells may be developed or fuel cells can be taken. So this type of things, fuel cells, as are generating electricity directly, so that type of fuel cells are generally used for one kind of hybrid electric vehicles, or fuel cell driven vehicles are also found. So in case of electric vehicles, there may be batteries or AC sources. As in case of overhead system trains, there will be AC sources, or in most of the road vehicles, that will be battery driven. So we can see that the fuels are being filled in the tank, and this vehicle will run with the internal combustion engine, and electricity is given to the car for charging its battery, and which will be called as EV or electric vehicles. So till that point, we have to discuss about the component of electric vehicles and the fuel vehicles. But here we will discuss about the components in detail. So how the mechanical force is generated. So till now we have only understood the fuel tank and internal combustion engine. So there will be several components which will be confusing. So I will gradually say go towards the power transfer, or it is called the power transmission in a particular vehicle. The power transmission system will be found both in automobile and in electric vehicle. So first of all, we understood the difference between the electric vehicles and automobile driven by the IC engine. And IC engine is replaced by electric motors in electric vehicles, and electric motors cannot run by its own, so electricity should be fed. And for giving the electricity in a road transport system, definitely we have a storage device which is nothing but our battery. So key component of a gasoline car are listed here. We have already discussed. So first of all, one auxiliary battery will be there. Electronic control module will be there for controlling so many electrical or electronic systems in a particular fuel car. Then exhaust system will be there. Means in the IC engine there will be the carbon dioxide generation, and that will be sent out from the car. Otherwise there may be explosion. So that type of gas outlet will be there. Fuel filter will be there before sending the fuel inside the IC engine. That should be filtered out so that there will be no dirt and all. Fuel injection system, there will be some nozzles so that with a controlled amount fuel will be injected inside the engine, and so that the fuel economy is maintained. And there will be a fuel line or pipeline, that means connecting the fuel tank and the IC engine. And for sending a liquid, we always need a pump. So definitely there will be a fuel pump which will pump the will take the responsibility for pumping the fuel from fuel tank to the sending it to the IC engine. And fuel tank means storage unit of the gasoline or liquid fuel. Internal combustion engine, which is the main part of the automobile driven by gasoline fuel. And the transmission. This transmission I am going to discuss about. This transmission unit is nothing but the unit which will transfer the mechanical power from engine to the device in the driving wheels. So automobile components, engine, powertrain and body. So first of all, body will be found from the outside. Then there will be other main part which will be the IC engine, and then there will be another main part which is powertrain. So in most of the cases, this powertrain is not known to us very well, because it is a very complex and mechanical system, and it is generally taught for the automobile engineers and mechanical engineers. In many cases, if we are studying with the other streams, that may not be say come across, may not be in the syllabus, or we might not have been come across to this. So automobile powertrain is the system which transfer the power from engine to drive wheel. So why it is called powertrain? Because there are several components which is connected, just like a wagon, and wagon means part by part, which is found in the case of a train. That's why means it is a chain, or it is a say combination of say connection of several components. So it is connected one by one. So that's why it is called powertrain, where the power is transmitted from one part to the other part with the help of different components. So IC engine, as I have told, that is a very complex mechanical device, and that mechanical device is running with the fossil fuel, which will be a liquid burning element, and that inflammable element, and that is sent to a particular cylinder, and that cylinder will have some piston which is moving in a linear direction. So in a particular IC engine, depending on the design and power rating, there may be several cylinders, and all the cylinders will be running say in a particular fashion, particular rhythm, so that the linear motion of cylinders are converted into the circular motion with a particular mechanism, and all the circular motions of the cylinders, means of the linear motion of the cylinders, are converted into circular motion, and all the power generated by each cylinder will be found at this shaft. So this is the main shaft, and where the gear will be connected, and we can find a particular amount of power deliverable at the shaft of the engine. So, and that engine will be connected to a transmission system, So as we have seen that engine will be connected to transmission system so that the engine power will be transferred from engine to the driving wheels. So we will see the animation of a particular cylinder. We can see that some blue color material is coming inside the tank and some spark plug. This is a spark plug. It is giving some spark so that it is burnt, and whenever it will catch fire, it will create some pressure by which the piston will come down, and it will be giving some circular motion, or it is creating some circular motion by this mechanism, and we will get some exhaust also. There will be several valves, so it is the opening for inlet of the liquid fuel, and it is also opening for sending the gas for outlet. And this type of engine, this type of cylinders are combined with several numbers for getting a large amount of power. Now if the fuel injection is less, then the movement of the pistons will be less, and we can also get lesser motion. But whenever we will give, if you need much amount of power, so we will be injecting lot of fuel with the help of say accelerator, and that fuel burning will be fast and faster, and we will get some comparatively higher motion in the shaft of the engine. So we can see that pistons are moving very fast, and it is giving a lot of power. Okay, so this is the spark plug. Here there will be two tips. Between these two, electric spark will be generated, and which will be used for setting up the fire here. Okay, but for IC engine, there the RPM will be around say 1000 RPM for a particular IC engine, and that 1000 RPM is not suitable for giving the power to the wheel directly. So in all the cases, the IC engine shaft is not directly coupled to the driving wheels. So if the IC engine is here, it is not directly coupled either, neither for the front wheel nor the rear wheel, because we need a very less motion during the starting. Because if we put the car in a particular high speed at the starting, there will be a jerk, sometimes accident may be there, also it will not be comfortable. So we need to move the car very gradually with a low speed, and then it will pick up its speed so as soon as it will go for a particular distance for comfortable driving. And for that we need to reduce the speed, number one. Number two, whenever the car is at standstill condition, for overcoming the inertia, the car's power or the torque available at the say driving wheels also is much more. So we know that whenever for a particular system, if mechanical power is fixed, and if we consider the torque and the RPM, the rotational motion, so if we reduce the RPM, we see that the torque increases. So definitely at the lower speed, if we reduce the speed, definitely we'll get a large amount of torque. So what is done, there are several gear system, because we have seen in mechanical system, if we want to reduce the rotational motion, then we need to use different gear ratio, and that gear ratio is nothing but the ratio of two gears which has different number of teeth. So for that type of achievement, means when the car is going to start, we need to have lesser speed and higher torque. We can obtain it from the IC engine with the help of a gearbox, where there will be several gears, several diameters, and several number of teeth, and utilizing the manual transmission unit, whatever is controlled by the driver, and with the help of a clutch, we can set a particular gear. Depending on the gear teeth number or the size or diameter of the gear, we can get a particular speed for moving the car very nicely as per our requirement. And now what is the clutch? Who have driven the car or who are driving, so definitely they are very familiar with that type of device. So clutch is nothing but a device which is disconnecting the gear system from the IC engine shaft, because during the changing that should be disconnected, and whenever the gear is placed at a particular position for connecting or combining it with the IC engine gear, so definitely whenever it is done, we will again connect them together and we will get a different amount of speed. So in most of the cases, the roads are combined with some steep and down, and also from flat roads. So in the flat roads, the torque requirement is less and speed requirement is more. In case of up, the torque requirement is more, speed requirement is less. So that type of situations are handled with the help of the gearbox, where there are several number of gears with different diameters and different number of teeth, so that we can change the number of RPM. With the change of RPM also we will get the change of torque. So here you can see some animation where you can see that the cars are moving on a steep area where we need a particular amount of torque which is larger than the requirement for a flat road. So torque is more, or torque requirement is more here, and speed requirement is less, and that is considered, that is obtained by the help of a gearbox, which is say shown by this animation. The input power, and we are getting some output power with the help of several number of gears, and the arrangement of the gears are designed as per the requirement. Okay, so these are already discussed powertrain. So first of all, there will be steering. Steering will be a device which will say change the position of the front wheel, which will give us the direction of movement, and also there will be some clutch and the brake also, because whenever we want to reduce the speed or stop the car, definitely we need to apply the brake. But definitely before applying the brake, we need to have a particular gear system which will be connected to the engine, because stopping the car at a very high speed means whenever the particular gear is there for high speed, if you want to stop, there will be a jerk and also accident may be there. So car engine will have a particular situation which will not be suitable for its smooth operation. So definitely we will generally stopping a car procedure is that we need to reduce the speed gradually. Whenever it will move in a particular less speed, we will press the brake, and whenever it will be almost stop or it will be stopped, then we will put the engine in a neutral gear. Neutral gear means it will be engine will be started, but there will be no motion or there will be no power transmitted to the wheel. So it will be running freely. So components of the car is found as engine, clutch, gearbox, driven shaft, differential, and drive wheels. Now in these terms, we have already covered engine, IC engine, clutch we have also understood, gearbox also we understood, driving shaft and differentials are all known. So I will tell that if the engine is there by this picture, and if the wheels are the driving wheel here, it may be rear wheel or it may be front wheel depending on the design. So the power will be transmitted from the engine to the rear wheel through several components, and the arrangement of this component is called a train, and as the power or mechanical power is transmitted from this point to the wheel, meaning engine to the wheel, through these components which are connected like a train or the combination of one by one. So that's why it is called powertrain. So the train which is transferring power from one part to the other, and the first part is engine and last part is rear wheel, so that we can get the mechanical motion in the wheel so that our car can move. So now, we will be discussing about the transmission unit or transmission system units, starting from the say gearbox and the drive set. So drive set and the differential are the key part of the transmission unit. So first of all, the IC engine is understood. Then IC engine will be having several number of pistons or in the cylinders, and these are the parts of that. Who are mechanical engineer, they will be very familiar with this. Even the electrical and communication engineer, after studying or after going through those slides, I think they will also have some idea about the components, how the engine is working and for what purpose it is installed in a particular car. And this is the gear system. There will be several numbers of gears, 1, 2, 3, and 4. Even there may be fifth gear, and there may be some another gear which will be called reverse gear. So whenever this gear will be activated, so car will move backward, so that we can get the motion in the backward also, which is very, very important for during the parking and some other situations. And for all the type of gear changing mechanism is also executed with the help of clutch whenever the gear box will be disconnected from the shaft of the engine. And now I will come to the differential. So this is the engine which will generate the mechanical power, and that mechanical power will be coming to the gearbox, and this gearbox will give us a particular rotation, say RPM, and also torque. And then this mechanical power will be connected to a particular straight say cylinder, which is called an axle, but this type of axle is called drive axle. And this drive axle is connected to one kind of device. It is also gear mechanism device, or it is also the combination device combined with some gears. So that type of device is noticed by many people who might have been curious in their childhood. Even I also noticed several times during my childhood, but I didn't know what is that. So I had a lot of curiosity during that time, that what may be this device, why that type of device is there. So this is nothing but the differential, and that differential is found in between the two drive wheels. We understood drive wheels. Drive wheels means where the mechanical power is given. Say if these wheels are the rear wheels, then it will be connected to this device at the near the rear wheels. So now for this picture, the drive wheels are connected to this differential, or differential connected to the wheels. Those wheels are called drive wheels. Now why this type of different device is required? This is called differential because in case of the vehicles, when the vehicles are moving or in a curved place, or it is taking a turn. So if we assume that this car or this system, automobile system, is moving at the left side, means it is taking it is going along a path which is in a curvature in nature, and that is in the curvature is in the left side, means the center of the curvature will be at the left side. So what will happen, the distance which is required to be covered by this wheel will be much more compared to this. But if the RPM of this wheel and that wheel are same, then what will happen, this wheel will not be able to cover this distance at the same time, because RPM multiplied by time will be some distance which is say covered by a particular circumference. So automatically we will be understanding that if the speed of this wheel and that wheel are same, and if they need to cover two different distance, it is not say suitable. So one wheel will be slipped. So definitely this wheel will be slipped and this wheel will run nicely. So in that case, one kind of machine or one kind of component is required, which is called differential. And as the name suggests, it is giving two different speed to these two wheels during the curvature. But when it is running along a straight line or straight direction, both the speeds should be similar and it will be similar. So this differential will work in such a way that whenever it is moving in a linear direction, then what will happen, they will get the similar RPM. But when it is taking a curve, so the different speed will be imposed. So whenever it is turning at the left, so speed of this wheel will be more. When it is turning in the right, so speed of this will be more. So that's why, as the speed of these two driving wheels are different in nature, and as this phenomena is executed by this machine or this device, this is called differential, and it is very, very important for all the say automobiles, and that's why it is found by most of the automobiles at the driving wheel system. So this is a cross section of the wheel system, transmission system of automobile. If this direction is called taken as assumed as the front axle, then definitely it will be engine will be near to the front wheels, and after that it will be flywheel, it will be gearbox, yellow color, and then there will be the driving shaft or propeller shaft, because the gearbox power is being transferred to the differential by this axle, and there are several joints, it may be at least one or two, and the joints are called universal joint. Universal joint, why these are called universal joint? Because if the axle of this gearbox and if the axle of this driving unit, that is differential, are not in the same plane, then also the power will be transferred by these mechanical devices, which is called universal joint, as they can transfer the power from any plane to the other plane, or any axle in a particular plane to the other plane axle, then it is called universal joints, and then it will be giving the power. So power is coming in this direction and it is divided in 90 degree, and the power is divided in 180 degree here, and so performance of differential is that, so the power coming in a particular direction, it is divided and it is transferred to the 90 degree direction, and also it is giving two different speeds. So these are the two major performance or function of differential. So transmission system component parts, so in detail it is there. So gearbox I have already mentioned, differential and how the differential will be working I have already mentioned. So this will be the engine, then gearbox. In the gearbox there will be the transmission, and this is handled by the driver manually. That's why it is called manual transmission. And then power will be transferred to the shaft, and this is called drive shaft or propeller shaft. Propeller shaft will be connected to the differential, and differential will divide the power to the both the driving wheels, and also it will give two different rotational motion facilities. That's why it is called differential. And we can see that the say propeller axle and this axle are not in same plane. You can see that much higher because engines are at the top and the differential at the particular bottom. There may be say 1 feet distance between these two planes, but still the axle is running and transferring power nicely. So this type of joints is called universal joint, as I have told. So you can see that if the axis of this and this axis are not in a particular plane, then straight transfer or the straight arrangement of the drive will be not found. This driving shaft will not be found. So there may be some angle if the engine is at the top and if the difference is found at the bottom level. So in this situation, the joints which are called universal joints are very useful. So rear universal joint and front universal joint also found. There may be one or two. So here by this animation we can see that the driving axle or the propeller shaft is giving the power, and this is a ring gear, and the red color gears are called the spider gears, which are arranged in such a way that we can see that the power is transferred by this arrangement to a 90-degree direction. So two powers are divided in 180 degree, as well as if we have the larger speed requirement in the right side, it will be able to get, and if we need the larger speed requirement on the left side, it will also get with the help of the arrangement of the spider gear and the ring gear. So the entire thing is enclosed by this device and known as differential. So these are the very important for any vehicles, either fuel vehicles or electric vehicles. So we will be also say aware about that. So now we are already gone through all these mechanisms of how the manual transmission is say working. So there will be the mechanical gear changing device, or the gear knob will be there. We will be placing that in a particular time whenever the power and whenever the torque and speed requirement is there, we will be changing that gears with the help of. But in many cases, the gears changing or the shift in the gears are made automatically, and this system is called automatic transmission system. So this is transmission system but manually. So by this manual device we can change the gear position. But in case of automatic transmission, there are some gear system which is called planetary gear, and by this animation you can see there are several gears connected. So this is one kind of ring gear, and that ring gear contains three smaller gears which are connected to the periphery of the ring gear, or the directly connected to the ring gears, and the other bigger gear which is at the central, which is placed in the central position, and which is also coupled to the other gears. So this is called planetary gear. Why it is called planetary? Because this system is similar to the solar system, where the sun is there in center and there are other planets, and those planets are revolving and with their own axis, and also it is which is moving or surrounding the sun also. So this type of system is compared to the planetary system or planet system, and that's why it is called, this gear is called the sun gear, and these gears are called planet gears. So this type of gear systems are used for changing the speed and torque in a particular transmission system, which is called the automatic transmission system. And the bearing, it is very familiar or well-known device. It is starting from one bicycle or any other smaller bike, even kids bikes also. That type of bearings are there. Even in our, any rotating devices like machines and fans, we found that type of bearings. It is the device which reduces the friction. It may be having some balls, hard material or metal made some balls or rolls or rollers. So that type of bearings are sometimes called roller bearing or ball bearing. It is entirely for reducing the friction. So now we will come to the say type of the drive. So whenever I told that the drive wheels which is connected to the differential, means the wheels where the power is transmitted. Power is generated in the IC engine, then it is coming to the gear system, and from the gear there will be a propeller connection or propeller shaft, and which will be connected to the differential by this red color device, and the differential will divide this power in a 180-degree direction, and it will be giving the power to this wheel. So these wheels will start moving. Whenever these wheels will start moving, automatically these wheels which are free to move, they also move. The car will move in this direction. So now these wheels are, say, if as per the design or as per the drawing, if these are wheels are at the back side of the wheel, back side of the car, or if it is put at the rear side of the car, then it is called rear wheel drive, because drive wheels are at the rear position. In case of the front wheel drive, the engine will be there and the differential will be also connected to the front wheel, and the front wheel will also get the power. So that's why these front wheels are called the driving wheel, and that's why it is called front wheel drive. But in case of the automobile or cars where the power requirement is more, two differentials are used. So from the engine power, one amount of power, certain amount of power is transferred to the rear wheels and certain amount of power is transferred to the front wheel. So there are two differential working as the same whatever is done for a single differential system, and here all wheels are getting power from the engine. That's why it is called all wheel drive or AWD. And now we will come to the components of the electric vehicle. So definitely we understood the component of say fossil fuel vehicles. We are aware about all the components starting from IC engine, fuel tank, and then differential, power transmission, everything, and then all the major things are covered. So now we will be discussing about the electric vehicles with some battery pack. So there will be some big amount of storage device which will have some larger capacity of storing the charge, and that can be obtained by a larger battery or smaller battery connected in series and parallel. Okay, so in most of the cases, the battery pack is developed as a multiple battery pack, multiple battery based pack, and that is called battery bank. So developing a larger battery having certain amount of charge storing capacity will not be very much economical or feasible if we want to get a large amount of power from this passive battery. So in smaller vehicle like say three-wheeler vehicles like auto and all, there may be say one or two batteries. Even for the two-wheelers, we found that one or two batteries connected together to drive the motor. But in case of four-wheeler, as a lot of power is required for getting a particular amount of distance for a particular charge or for a single charge, we need to have a lot of power to be stored. For that, in this case, many batteries are connected, similar or identical batteries are connected in series and parallel to get a particular voltage and current level, so that we can get a particular power level which is suitable for driving a motor for long distance. So for component EV also, there will be some mechanical devices, whatever we have discussed, except the fuel tank and the IC engine. All other mechanical devices will be also present in the electric vehicle, starting from the auxiliary battery also, and also another traction unit battery pack will be there. So this traction unit is generally installed at the bottom part of the electric vehicle, so that the CG of the vehicle is possible to be taken as closer as the ground point. So say for history, there will be several electric vehicles found in the earlier stage, which is not very developed, but nowadays we can see even the Tesla S model and many other companies are coming. Even in India, we have seen that Tata Motors and the Mahindra and all, they are also developing the four-wheelers, and these are available in our Indian market. And also government is taking so many steps so that the electric vehicles can be provided to the consumers, and there will be some schemes also are there. If we have say for the company will be some offered, there may be if we say for certain number of say battery, or if we go for say higher distance, we will be having some say options, so that we can go for 200 kilometers at a stage we can go, or sometimes it will be, if it is two-wheelers, it may be say 50 kilometers or 70 kilometers like that, which is not at all say solving our need. But still the research is going on, because if we want to install a battery pack with a larger distance, it will be, first of all, it will be very say heavy, which will not be suitable for putting inside a moving vehicle, because if the vehicle is very heavy, then it will be not economical and it will be very difficult to drag by a motor, and also the cost will be a major problem. So if we want to develop our car, there will be several researches required till now. A lot of people are working in this field. So starting from the two-wheeler, four-wheeler, bus and truck, all vehicles could be possible to be developed as electric vehicles, but having some limitations, especially in the distance covered by the vehicles. So starting from the two-wheelers, my self-balancing vehicles, our electric vehicles are called, say, these two-wheelers and the conventional two-wheelers, even for auto rickshaw and all small four-wheelers also, for six-wheelers, standard four-wheeler vehicles, and even some luggage vehicles like, say, more than six-wheelers, and electric trains and all. So now how EV works, because it has some battery, so definitely it has some electrical power. If we have one electric motor coupled with some gear system and all, the motor can be rotated nicely and we can run the vehicle. And this is the very basic principle of electric vehicles. So it is called as green vehicles or green technology, but whether we have to say have the entirely or 100% green technology or not, that we have to think about, because there may be some issues and critical issues which are going to be discussed in this in the later slides. We will see that. So first of all, how EV works, we understood that conventional vehicle four-stroke engine is used, which is definitely replaced by some battery and motor system. So source charger will be there so that battery can be charged, and then this battery energy is fed to an electrical circuit. It may be a DC-DC converter, or if it is the motor is AC, then it will be also with some other circuit called inverter. Then the control signal will be also coming from the dashboard or any other driving units, so that we can utilize that and we can control the power. And there may be also some battery management system like the BMS, which will monitor the battery life, charge level and discharge level, as well as some other parameters like voltage and current. So whenever the electronic circuit will deliver the power or transfer the power, then this power will be connected to the motor, and motor will run, and there will be some transmission system. So as I have already mentioned, apart from this motor and the charging unit and the electronic circuit, there will be some mechanical system which is similar to the automatic vehicle driven by IC engine. So after that, there will be wheels. Even for all vehicles there will be wheels, and these wheels will be driving wheels, and other wheels also may be there. If it is a three-wheelers, then if the driving wheels are two at the rear side, then the front wheel will be free wheel. And for four-wheeler, if the driving wheels are on the rear side, so back side wheels or rear wheels will be driving wheels, and other front wheels will be free, and there will be connection of steering so that we can move our vehicle in a particular required direction. So EV type, battery power and solar power, that I have explained in the first few slides, that there may be some solar power system, but that will have several limitations. Otherwise it may be DC and AC, so that also we have discussed, and which is found as a traction devices. Otherwise most of them are DC devices. DC means battery type system or battery based system, but this DC power may be directly taken by a DC motor, or there may be some AC motor. In case of AC motor, there will be also a requirement of inverter. Okay, so as per the number of sources, the electric vehicle will be classified into two types, either say electric vehicle or all electric vehicle or battery electric vehicle. So all electric vehicle means there will be no other sources, only the battery will be the sources, and it is called AEV, and the battery electric vehicle is abbreviated as BEV. Those are almost same, and all electric vehicle is abbreviated as AEV. Now hybrid vehicle, or say HEV, this will have say more than one source of energy. So why this type of vehicles are required? Suppose we are moving a particular direction and we have to reach a particular destination which is coming after 100 kilometer, and if our battery is finished, or if the battery charge is finished after covering the 50 kilometer, our car will be stopped say at the 50 kilometer or half of the distance to be covered. During the situation, two solutions will come. First of all, there will be one charging station where you can charge. Otherwise, we have to have some other means by which the car can be driven. So first of all, if the charging unit is there, there will be some other disadvantages. First of all, battery charging is not that much fast, which is found for say gasoline fed vehicles. So when for the gasoline vehicles or fuel vehicles, if the fuel is finished, if the fuel tank or fuel filling machine or fuel filling station is there, or petrol bunk is there, it will take hardly 5 minutes or not even more to fill the tank and to move forward again. But in case of electric vehicle, that may be say taken at least 1 hour, or even it may be several hours depending on the design of the charging circuit and the vehicle. So if we are in hurry, or if we have to cover a particular distance with a particular time, so that time is very, very crucial. So during the situation, it is found it is more advantageous if the another feedback or another backup system is there. So that backup system may be another engine, that may be another IC engine. So IC engine can be also coupled in a single vehicle where the battery based motor drive is also there. So in this type of systems, we find two sources of energy and two sources of mechanical power generation, and that's why it's called hybrid vehicles. So if IC engine is there and if battery driven motor is also there, then what will happen whenever our battery charge is there, we will monitor from the dashboard. The battery charge is there for 100 kilometer, and we will drive the car as soon as battery is there. If the battery is finished, we will run the car through the help of the IC engine, and IC engine will get the fuel. That fuel also will come from a tank, because as the IC engine is there, definitely there should be a fuel tank and fuel pump all system, and that will help us to drag the vehicle by burning the fuel. So whenever we will reach the distance, we will see that our battery is already finished, because we started our IC engine for that. So definitely we will put our car in a charging unit and we will go to the office or anywhere else. We will finish our work. If there are several hours to finish our work, during that time the car will be in charging mode, and it will our battery will be being ready for the next drive. So whenever we will come back from the work, we will disconnect from our car from the charging station, and you will see that our battery is again full, and we will drive the car fast with the battery. And whenever we will see that battery is almost finished, we will again shift to the hybrid engine, second engine, that is IC engine, and we will run through the IC engine based driven system. And in the destination or in the home, whenever we will reach, we will again put our car in the charging. So in this nice way, we can shift our charging, the driving system, and we can utilize our long distance drive. So for that reason, several types of the hybrid vehicles are invented, and for EV and fuel vehicles there will be several comparison we have already discussed. So here major benefits of the electric vehicle is that no fuel consumption, so it will be helping for preserving the fossil fuels, no pollution, noise free. Noise free sometimes disadvantages, because some miscommunication or the confusion may be created in the road whenever people are walking together along with the vehicles, so they will not be aware about some vehicles which is coming or just behind them. So there may be some chances of creating some accident or miscommunication, so that is a disadvantage, and that's why few companies are putting some artificial noise maker inside the electric vehicles. Easy recharge process, so charging process is time consuming. That process is very easy, even by the driver already you can do that. So refilling the liquid fuel is not that much easy, because we need to have some monitoring, and we need to have some say mechanic or some helping person may be required in many cases. So drawback, I have already explained, high initial cost, but the advantages will be low running cost. Now I will come to the charging station and the battery charging, how the battery charging is done and why the smart charging is required. So first of all, I will discuss about one unit which is called multiple charging unit, which is used by our say personal use, which is called charging dock. So this type of devices are very much useful during our day-to-day life, because for the facilities we may have several mobiles and iPad and some other gadgets for us, for the adults, for the kids, and we know that all devices are running through a battery, and those batteries are required to be charged again and again. So whenever we will have more number of devices, it is very difficult to connect for different charging port, because several ports may be there, and also it will not be very difficult, but it will be not comfortable. So that's why one charging unit will be used, and that charging unit will be taking AC power from a one plug point, and it will deliver DC power to all of them. So similar thing is happening if we connect all the electric vehicles or many electric vehicle in a particular region. So what will happen if we keep increasing the number of devices? Definitely the current will be more, and all the current will be additive in nature because all are connected in parallel to this system. Similar thing will be happening in case of electric vehicles also. So a lot of current will be taken and a lot of power will be consumed by electric vehicles. So if the vehicles are number of vehicles are observed in a particular country, you see that it is exponentially increasing, and that is creating a particular impact on electrical power system. And that electrical power system has to have the capability of withstanding or keeping the balance between the power and supply and demand. Because if one power system is developed, definitely it will have a particular capacity of delivering power depending on its supply capability. And if those things are not matched, the power system will be at the time when it may lose its control or stability. So there should be some procedure by which we can monitor how much power is taken by say what type of appliances, either it is for the say conventional appliances like domestic and commercial lights, fans and all, or otherwise it is this power is drawn by the electric vehicles. So if we have a monitor or a particular statistics by which we can monitor all the vehicles, that which vehicles are connected to which part of grid or microgrid, and then the power is distributed accordingly or not. So that type of monitor is very much important. Otherwise, the grid stability may be hampered. So I will just explain the how this can be done. So I am just skipping the slides which I have explained. So generation of the carbon dioxide and this thing, all these things will be coming in the impact on the environment. So those impact are already discussed. So now we are here to discuss about the impact of the electric vehicle on the power system, as what is the requirement of this, the smart charging procedure. So I will skip all these things because I have already discussed, and I have put these slides as a summary. So there will be several slides for explaining all these components. I have whatever I have already discussed with the other slides. Okay, so I will explain 3 slides here for discussing about the battery electric vehicle schematic. That means I have already told that when the battery is only one power, then this power is taken to the electric motor and it is driving the wheels either rear or front. Then there will be one plug, and which plug will be connected to the DC supply. So if there is one board here for charging, definitely it may be AC also. So this type of board or charging unit or this type of vehicles are called onboard charging vehicle, or the charger will be called as onboard charger. Now if the charging unit is there outside, so DC will come here, and this type of board is called outboard charging system. So the DC is all will enter to the circuit and it will be connected to the battery. Now in case of hybrid vehicles, hybrid vehicle may be plug-in hybrid or non-plug-in hybrid vehicle. So plug-in hybrid vehicle, that is PHEV, that type of vehicle, as the name suggests, there will be a plug. And why the plug is there? Because there will be 2 engines, because hybrid means there will be at least 2 engines. So fuel tank will be there, and IC engine will be there, and battery pack will be there, and one motor will be there. Now battery will be charged from the outside source. So there will be one plug. That's why it is called plug word will be there. But in case of non-plug-in vehicle, that means we will not see any plug coming out from the vehicle. So that means the charging unit or charging procedure will be done sorry, by the component already installed inside the car. So what will happen? The fossil fuel will be taken from this tank. IC engine will run. By this power, the generator will run. This is one electric generator, because this is one prime mover, so it will have motion, mechanical motion inside the shaft, which will be transferred to the generator, and generator will generate electricity, and there will be some converter. If it is DC generator, it is okay, we can give the power, but still there will be some regulator circuit which is omitted here for simplicity of the picture, and it will charge the battery, and that battery will give the power to the motor, and motor will drive the wheels. And in this way, no output power or electric power is required for charging the battery as a plug point. So that's why there is no plug, and it is called non-plug-in. Okay, so this is the animation for how the say battery is giving the power to the motor, and how the IC engine is giving the feedback to the battery, so that the generation of DC power which will be connected to this, and for charging the battery. Sorry. So hybrid car, how the hybrid car is working and on all. So I have discussed that. So there will be electric motor. Here you can see that electric traction motor. This is the traction battery pack, fuel tank. So battery pack will be there, tank will be there, IC engine will be there, motor will be there. So two separate energy systems, and that's why here you can see that the plug point is also there. So it is called plug-in hybrid. So these are the component of or the structure of PEV. Another type of vehicles, as I told, that fuel cell vehicle will be there. So also battery pack will be also there, and fuel cell. This is the fuel cell stack, or there will be several cells, which is called fuel cells. Fuel cells are the device which will convert the chemical energy into the electricity directly, and the fuel for this fuel cell will be hydrogen, and the combustion gas will be oxygen taken from the air. So I will explain that in some slides. So for the I will go to the fuel cell vehicle. So these are all discussing about the say hybrid type of vehicles, where you will see that either full hybrid or micro hybrid or mild hybrid. In micro and mild hybrid, there will be one electric motor will be installed, which will be helping the internal combustion engine for dragging the vehicles. And depending on the mechanism and the facilities or the other systems of dragging the vehicle, the level of the hybridness will be changed. And there are some vehicle simulation where you can go through the site and you can work on the simulation also. Plug-in hybrid vehicle we have already discussed. So we will come to the fuel cell electric vehicles. In the fuel cells, what I will see that we will see that there will be one channel for hydrogen inlet and one channel for oxygen inlet. So now what will happen, there will be a tank which will have some hydrogen, and that hydrogen will be coming to the fuel cell, and oxygen will be taken from the air, that will be mixed, and the burning will be there. There will be exhaust, some heat, and some water vapor will be coming out, and that fuel cell output will be electricity, and that electricity will be running or suitable for running the electric motor. So this is the animation where the hydrogen gas is entering, oxygen is taken from the atmosphere, and there is some electricity generation, and that electricity will be taken for driving the motor, or it can be taken through the battery. So that fuel cell power will be taken to the storing the battery unit, and then it will be feeding to the motor. So here we will see that worldwide number of battery electric vehicles used in the 2012 to 19. So battery electric vehicle BEV means only battery is there, no other engine. Fine. So it is also increasing in the exponential order. You can see that starting from 2012 to 2019. Now here global annual sales of plug-in hybrid electric passenger cars and plug-in hybrid vehicles. So electric vehicles either in battery EV or say plug-in vehicle, all are increasing with time. So there will be a lot of vehicles. Few manufacturers are listed here, and few models are listed here with their price and all. So we see that a lot of say vehicles will be connected in a particular grid if it is not monitored properly. So till now we have understood that the battery electric vehicle or plug-in hybrid vehicles are increasing in number. They are serving us our purpose for transportation, and a lot of vehicles are purchased, and this number of the vehicles running on the road in electric mode are increasing. Definitely battery will be there in everywhere, either in plug-in or in battery electric vehicle. Battery is required to be charged again and again. So for charging a battery, we need that a source which will give the battery source, and that charging can be taken from either particular battery which has the capability of delivering power to another battery. So this battery is working as source, and this battery will be working as load here, or any other battery source, or any other DC source which will convert any kind of power into the DC source, and that power will be transferred. So as a thumb rule, battery should be fed with some DC power so that it can be charged. So rectified DC power supply is very popular for our that. What is the rectified DC power supply? First of all, there will be one transformer, because our grid power is delivered a single phase, it will be 220 volt in India, and that voltage is not suitable for or may not be suitable for charging battery at that level, because battery voltage, if it is say 12 volt, then the voltage power will be delivered to the battery at that voltage level. So definitely 220 volt is much higher than that. So first of all, it will be transferred to a lower voltage level which using the transformer, and then that will be also AC, and definitely AC will not be possible to be connected to the battery for charging, because battery delivers DC power. So definitely for charging, battery should take the DC power. So definitely it should be rectified so that we can get DC power from the AC power, and then it will require some filter, because rectifier output will be pulsating in nature. It will have some fluctuation as we studied in our basic electrical, and then there will be some regulator circuit, so that the variation in the input side anywhere in the other stage will not affect the output voltage. So as for example, DC power supply regulator. So this type of chargers are found in many cases. Simple battery chargers, which is used for charging our pencil battery, used for many gadgets like watch and toys and other clocks. In the mobile charger and laptop charger, any other big battery chargers. So basics of the battery charging circuit is that transformer will be there, that will be step down in nature because we want to reduce the voltage. After that, there will be some rectifier circuit. As for example, I have given the bridge rectifier, and then there will be capacitor banks or any inductors connected suitably for reducing the ripple of the battery rectifier output. So after that, there will be some regulator ICs denoted by this type of ICs. This will be used for some low power devices charging, but that may differ from other hyper charging also. But regulator circuits must be there for regulating the sources or regulating the supply voltage. So first we will have 4 stages. First, step down or transformation of AC level voltage, then rectification, then filtration, and then regulation. Then we will get suitable power at the end, at the output of the battery charging circuit, which is combined by these 4 steps, and we will be connecting the battery for charging. So there are several charging types and levels for electric vehicles. The high power device, because battery need to be having the capability of delivering the power for long time to cover a long distance. Definitely big battery or battery bank is required to be used, as we have already discussed. So now the level 1 charger, say it is for larger amount of time, so we can see that say 12 to 18 hours, and for level 2 chargers it will be lesser time, but for DC fast chargers it will be having some more lesser time. It's for at least say reduced time, most reduced time, and it may be lesser than an hour. So this type of charging facilities will be obtained and may be found similar in many countries, but that from one company ABB I have just taken from the internet. That's why I have given that for example. Okay, for any charging circuit, there will be some charging port we will connect, and the vehicle will get some electric power to charge its battery. Same thing will happen for the battery charges, what I have already explained in earlier slide. So whenever the number of batteries, number of electric vehicles will be there, number of batteries will be there, and number of batteries are more, that means the power consumption will be more. So now if we don't monitor and don't say control, the grid will be in trouble. So I will just quickly go through those slides where we have seen that how the battery is developed for electric vehicles. So we can see that many battery cells are connected together, so for developing one that. So why the batteries are developed with many cells? In one more advantage is found that if it is developed with many cells, then the heat generated by the battery pack will be dissipated, because there will be a lot of spaces in between the cells, smaller cells. Now for smaller battery means it will have lesser voltage and lesser current level, but for driving an electric motor suitable for the electric vehicle dragging, definitely there should be a particular voltage and current level. So how the voltage level and current level are raised for series and parallel combination? So for parallel combination, current level is increased, battery voltage level is fixed, and for series combination, voltage level is increased and current level kept same. But if we go for series and parallel, then we will get a particular voltage and particular current, so that we can get a required amount of power deliverable to the motor. Battery may be different kinds, either lead acid battery or lithium-ion batteries. For charging, there will be several batteries may be connected in parallel, but the charging current will be taken as per their battery rating also, whether it is lead acid and whether it is nickel, cadmium or anything, that will not much affect the property of the rectifier output. So the battery charging circuit has to deliver as per their voltage and current rating. So the material will decide what is the performance will be during the discharging. So it can store for a long time, or its volume will be less or larger. So but as per the requirement, the volume should be less, weight should be less, and charge capacity will be more. So that will be ideal case, and for that lithium-ion battery are very popular because it has lesser weight compared to the lead acid battery. Okay, so lithium-ion battery has revolutionized our appliances. We have seen that our mobile phones becomes very slim day by day, and this is due to the improvement of the battery circuit. Same thing is found for our uh, uh, electric vehicles also. So the lithium-ion battery means lightweight battery, but still it will have large capacity. That means it will be very advantageous for the vehicle will be lighter, and our charge capacity will be more. So I will not go in detail with the lithium-ion battery and all, but still I will tell that there are a lot of say improvements are still to be done for long distance driving vehicle design. So lithium-ion battery charging, I will just keep that. All these are already developed, already discussed. So I will just, these are the explaining the battery charging circuit. Source and load already known to us. So I will just come to the point. Where I will start from the smart charging. So the smart charging will be very much required, otherwise the grid stability may be in danger. So for that we need to monitor how many electric vehicles are connected at a time and how much load is imposed by this total number of electric vehicles. So suppose there are already other appliances connected in that domain, so that domain can be controlled or supplied by a particular grid or microgrid. Then what will happen, some fridge, television and all are running parallelly for a particular region. There may be some commercial consumption also, industrial consumption also there may be. So apart from that, there may be some other electric vehicles. So when the suppose grid was designed, if it is not designed by consideration with the electric vehicle, then that will be very difficult to handle. So what is the solution? So depending on the demand and supply, we need to monitor, and there may be some connection devices or interconnecting network must work, which will monitor the how many vehicles are in the queue and how many vehicles are requiring the charging procedure, and that can be done by Internet of Things, because nowadays, say the power of internet, we can connect all the electronic components to electronic devices, and we can give some signal and receive some signal to and fro the devices. So with the help of Internet of Things, we will be controlling the power delivered by the grid, and that grid is called smart grid. Now what will happen if we know how many cars are waiting and how many cars are under charging? We can calculate the amount of power which can be handled by the grid. So that type of things can be also controlled, or the power demand increased by the vehicles can be also supplied by some other non-conventional sources like say solar and wind and all. So what will be there if the requirement of the power is more? So that time any other charge or the power generation units, say wind generator or the photovoltaic generation system, can be incorporated in the grid to compensate the power demand, to supply the extra power raised by the electric vehicles. So that will solve it, other purpose also. First of all, the grid stability will be maintained, and for the other reason, if the power demand by the electric vehicle is maintained by the say any thermal power plant, whatever is generally found major power generating units in our country, if the thermal power plant or many countries still thermal power plants are utilized for delivering the major amount of power, then what will happen? The electric vehicles are assumed to be the green. It will not remain the green 100%. Why? Because the power demand increased by the electric vehicles or raised by the electric vehicle will insist us to run the electrical thermal power plant more with more generation capacity of delivering power, so that more coal will be burnt, and more coal burning means there will be generation of higher amount of carbon dioxide, which will also increase the pollution. That means the reason behind the generation of carbon dioxide will be the electric vehicle if the thermal power plants are used. So in this domain, we can tell that if the power demand increased by electric vehicles are handled by any renewable energy sources or say non-conventional energy sources like the solar cell and the wind, which will not generate any carbon dioxide, then what will happen? Due to the electric vehicle, no carbon dioxide generation will be increased. So that in this situation only, we will tell our electric vehicle 100% green. So that will be advantageous for controlling the pollution. Otherwise, indirect effect of carbon dioxide generation will be there coming from the electric vehicle. So it is our aim should be that the increased demand due to the electric vehicles must be compensated by, say, greener power generation technologies, so that carbon dioxide generation will not be increased as well as the grid stability will be maintained. So that is the key point for the smart charging. So for that, we utilize the artificial intelligence technique, which is the mimic system coming from the brain structure, and which can be having several say algorithms working with either machine learning techniques or deep learning techniques, which will be trained by the several amount of data, huge amount of data, so that the computational system can get a pattern of the data, and the particular training or the information will be gathered from the data. So whenever it will go through that large number of data, it will start understanding that what is the pattern of data, and whether some unknown data will be given, so it will also try to match with the pattern, and it will give some comment and some arguments, and automatically it will be solving the practical problem. So utilizing the power of artificial intelligence such as machine learning and the deep learning, some algorithm can be written by which we can get some facility for monitoring the electric vehicles, and which will help us to charge them with the smart charging facility. So in recent times, we have found that many researchers are working on the smart charging studies, either with the practical data or with simulated data, and they are either working with some MATLAB simulation based software or with the help of their own software and developed with some their either machine learning technique or say other neural network techniques. So they are utilizing their computational power to study their algorithm, that how the smart charging can be implemented to control the pollution as well as to increase the efficiency of the power system. So Zheng et al. Earlier we have shown that they studied, they proposed a new technique for smart charging for electric vehicles and tested their technique with computer simulation. So they studied the simulation. So here we have seen that Zheng et al. They proposed an algorithm for studying the real-time EV smart charging. So what they did, the proposed charging scheme was based on a real-time water filling algorithm. So one particular algorithm they have used, and with the commercial as well as the industrial electric vehicle supply equipment host. So they studied the data with the electric vehicle which are used in the commercial as well as the industrial electric vehicles, and the results demonstrated that the monthly demand charges produced by the electric vehicles can be decreased by 20 to 35% for 35% EV penetration level without the depreciating the charging demand of the electric vehicles. And whenever you will go through the Wang et al. So there are many studies. I have few case studies I have given. They reviewed the research work conducted on the different algorithms for smart charging procedures of the electric vehicles, and the author mainly focused on that on their three different perspective in terms of the smart grid, and then aggregated oriented, and the customer oriented smart charging. And in terms of customer oriented smart charging, the stochastic optimization approaches has been studied to design the optimal schedule for the minimizing the charging cost of the individual EV customer. And sometimes the smart charging is also helpful for vehicle to grid. So if the charge demand is more, and if there are the facility to be to make the vehicles connected to the grid, means delivering power. Vehicle to grid means the vehicles are connected to the grid, and the grid demand is more, and at the time who has the lot of charge, but it is not required for driving the car. So during that time their battery charge, whatever is already there inside their car, that is utilized to the grid, and they are giving the power and converting into the AC, and they are delivering the power to the grid. So that technology is called vehicle to grid technology, even by focusing on this smaller scale of EV numbers within a microgrid. So it can be connected to a microgrid, so that the vehicle to grid technology can be utilized, and the power can be taken from any other electric vehicles which are not at all required for running the vehicle now. So the vehicle will be connected to the grid, and they will also deliver the power, and they will earn some money. So it was observed that the smart charging procedure of EV, the self consumption increases from 49 to 62 or 87, and the demand peaks decreases from 27 to 67. So the demand peak is reduced, and the result not only demonstrated that the benefit of the EVs for smart charging with PV power, but also provided insight into the effect of different charging strategies and microgrid composition. So they have studied with the PV based system or PV based supply incorporation in the grid, so that the demand is compensated by the PV based system. So there are many studies. So Ferrotti et al. They studied the electrical vehicle charging scheme under the uncontrolled charging regime, and as well as under the application of smart charging and vehicle to grid strategies. So whenever they studied two phenomena: when the smart charging is used and whenever mass charging is not used. The results demonstrated that for the uncontrolled charging, only a small portion of the transportation demand is fulfilled with a high photovoltaic capacity, whereas could better accommodate the photovoltaic energy sources could be better utilized with an intelligent charging to reduce the ramps. So ramps means ramps of the demand. So if the photovoltaics are systems are incorporated with this planned charging procedure, we can get a better system where the demand will be controlled, and also vehicle to grid technology can be incorporated. So with the conclusion, the electric vehicles are required to save the fossil fuels. EVs are also good for reducing the pollution created through the automobiles exhaust of fuel vehicles. PHEVs are required to ensure the long distance running, and PHEVs can increase the drive distance but also increase the initial cost definitely. But EVs and PHEVs may also responsible for pollution if the power demand is fulfilled by the power generation by thermal generation process. So EVs and PHEVs may influence a grid stability. So smart charging can provide a reliable solution both in reducing the peak demand and also giving the opportunity to the vehicle to grid technology. A number of research opportunities are there to explore the EV and HEV technology and their smart charging procedures. So I thank my supervisors and my collaborators with whom I have worked for several years and for gathering knowledge in different fields. I thank my institute NIT Durgapur for giving me the present situation and present position for continuing my research. And I thank Dr. Satyapriya for inviting me and for giving me opportunity to contribute in this field, in this FDP. And I thank the institute and the Department of Electrical and Electronic Engineering for giving me the opportunity. All the faculty members and organizing committee and the members of the FDP, I am thankful to all, And above all, I thank all the participants who are the part of this FDP, and without whom it is not possible to make this FDP successful. Definitely, as a speaker, I am very much thankful to them for their kind attention and patience for listening my talk. So thank you very much. So I'll be very happy to answer. If any doubt is there, I will try my level best to clear their doubts. Thank you very much.
Participants, if you have any queries, you can ask.
So if anybody has any questions in future also, I have given my contacts here, my email ID, my institute email ID, my phone numbers, my WhatsApp numbers, my Skype ID. So I'll be happy to interact with them in future also. So please don't hesitate to contact me if you have any doubts, as well as if you have any plan for the academic interaction or any say research collaboration. We are always open to say open for research collaboration activities. So if any kind of academic interaction you are interested for, just give me a call or send one email to my email ID. So I'll be happy to answer.
Yeah, good evening, sir.
Good evening.
Good evening, sir. This is Dr. Ilangu, Professor and Head Department of EEE, K.S.Rangasamy College of Technology, coordinator of this FDP program.
Thank you very much.
Question from student side, sir. As a coordinator, I would like to thank yourself for the past 2 hours. You are continuously taking so many aspects in the areas of electric vehicle. So many thanks to you, sir. Thank you so much.
Thank you very much.
There is no questions from participant side. Better MOC will take over the part. Thank you, sir. Thank you. Thanks a lot, sir.
Thank you very much.
MOC?
Yes, sir. Thank you, sir. Now I would like to invite Dr. P. Aravindan, Professor, Electrical and Electronics Engineering, K.S.Rangasamy College of Technology, to deliver the vote of thanks.
Yeah, am I audible?
Yes,
Am I
sir. Yes, sir.
Yeah. Good evening, one and all present over here. I, Dr. Aravindan, Professor, Department of EEE, K.S.Rangasamy College of Technology. It is my immense pleasure to propose the vote of thanks on behalf of Department of EEE and my own behalf to our today's resource person, the great personality, Dr. K.S.Rangasamy Bera, Assistant Professor, Department of EEE, National Institute of Technology, Durgapur. For readily accepted our invitation with his busy schedule, sir. It is our in our enlightened and then enthusiastic presentation, our participants get a large amount of input from the area of type of electric vehicle and then smart charging and then sources of electric charging, particularly hybrid electrical vehicle and then IoT charged vehicles. And the wide area of covering the entire theme of the ATAL FDP, sir. Definitely, we have a large amount of input from your informative and then enthusiastic presentation. Thank you once again.
Thank you.
Sir,
Thank you
for
very
your,
much. Thank you very
sir,
much.
for your inspiring and then inspiring presentation, sir.
Thank you.
Over
Thank
to
you very much.
Yeah, thank you, sir. Thank you. Over to MOC.
Thank you, sir.
Thank you, ma'am.
Thank you for all the participants. Tomorrow's session will start by 9:30 a.m. All kindly join. Thank you. Thank you for all the participants. Now the session is closed.
Okay, thank you very much.
Thank you, sir.